right, so picture this, 499 CE. You're in Pataliputra. It's a bustling city, right?
Yeah.
You've got merchants weighing out saffron, scribes keeping track of taxes, for the kingdom, and astronomers up at night just looking at the stars.
Mapping the heavens.
Exactly, mapping the heavens.
Mm.
Now, what connects these three things? Well, math, obviously, Russ.
Yeah.
And if you remember our last deep dive, episode 15, we saw how Aryabhata was already using math, like with shadows and stuff,
Yeah.
to unlock secrets of the cosmos.
Yeah, the universe.
The universe, right. But today, we're going even deeper. We're going into Aryabhata's understanding of arithmetic and specifically sequences.
That's right. So today's deep dive, we are going to be focusing on verses 19 to 24 from the Ganitapada, which is a section of Aryabhata's famous work, the Aryabhatiya. And these verses, what they reveal is really interesting. It's like a code.
Right.
We're going to see how Aryabhata understood arithmetic sequences and how to find the sums of different series of numbers, like triangular numbers, square numbers, even cubic numbers, and some very early forms of algebra problem solving.
So this isn't just ancient history for you, the listener. This is these math ideas, which might seem abstract now, were actually super practical back then.
Yeah.
So like merchants would use this for their business. Builders would use it for construction. Astronomers, well, they used it for their stargazing.
To make sense of the cosmos.
And so by looking at these verses, you're not just looking at old math. You're actually peeking into the foundations of math that we still use today. It's kind of like a shortcut to understanding some of the basic building blocks of how we think about numbers.
Right. So let's get started with verse 19, which deals with arithmetic sequences.
Okay.
The verse itself is samamula phala dvikam.
Okay, so what does that mean?
So the translation basically says, the sum is the root times twice. And at first it sounds, a little cryptic.
Yeah, definitely.
But essentially what Aryabhata is describing here is a method for finding the sum of an arithmetic progression.
Now, an arithmetic progression, what is that? Just
Right. An arithmetic progression, it's a sequence of numbers where the difference between each consecutive number is the same.
Oh.
So if you're counting by, let's say, threes, 3, 6, 9, 12, the difference is always 3.
Right. So consistent.
Yeah, exactly.
Like the steps are the same size.
Yeah.
Every time.
Yeah, exactly. And Aryabhata's method, basically it says, take the first and last number in the sequence, find their average, and then you multiply that average by the number of terms in the sequence. And this lets you find the total sum without actually having to add all the numbers individually.
Right, which would be a pain if you've got like 100 numbers.
Exactly. Especially back then, no calculators or anything.
Definitely not. Okay, so let's see this in action, right? Let's go back to our merchant in Pataliputra, right? Let's call him Ravi, the saffron merchant.
Okay.
So Ravi, on his first day selling saffron, let's say he sells 10 sacks.
Oh.
Right.
Yeah.
Now, each day, his sales increase by 5 sacks. Day 2, 15 sacks. Day 3, 20 sacks, and so on. Now, let's say you want to know the total number of saffron sacks Ravi's sold over 10 days.
Right.
You could add 10 plus 15 plus 20 all the way to, what would it be on day 10? 55, I think.
55.
Yeah, 55. But there's Aryabhata's first giving us a shortcut, right?
Yeah, exactly. Using Aryabhata's method, you would take the first day's sales, which is 10 sacks, and the last day's sales, which is 55. Add those together.
Okay.
That gives you 65. Then you find the average, so you divide by 2. 65 divided by 2 is 32.5.
Okay.
Then you multiply that by the number of days, which is 10. So 32.5 multiplied by 10, that gives you 325 saffron sacks.
There you go. Much easier.
Much faster.
So, Ravi or any merchant, if they're seeing this consistent change in their sales, their profits,
Yeah.
they could use this to quickly calculate totals, without, like you said, without a calculator.
Absolutely. Yeah.
And you, the listener, you might do similar things in your own life, if you're budgeting, tracking expenses. And here's Aryabhata figuring this out like 1,500 years ago.
Yeah.
Pretty impressive.
Pretty amazing.
Okay, so let's move on to verses 20 and 22.
All right.
These deal with sums of series. So verse 20, it says, Trikuza Sankhyavyatya, Samula Yoga Dvyata.
Right.
And this translates to the sum of triangles halved. And this is about triangular numbers.
Right.
Now, what in the world are triangular numbers?
So triangular numbers, think about arranging pebbles, for example, in the shape of a triangle.
Okay.
The first triangular number is just 1 pebble.
Okay.
The second is 3 pebbles arranged 1 on top and 2 on the bottom.
Okay.
The third is 6 pebbles arranged 1, then 2, then 3, and so on.
Got it.
So the sequence goes 1, 3, 6, 10. And you might notice each triangular number is the sum of all the natural numbers up to that point.
Oh, I see.
1 is just 1, 3 is 1 plus 2, 6 is 1 plus 2 plus 3, and so on.
Okay.
And Aryabhata's formula for finding any triangular number is n multiplied by n plus 1, all divided by 2.
Okay.
So the fourth triangular number, you would do 4 times 5 divided by 2, which is 10.
So the formula gives you the same answer as if you actually arranged the pebbles.
Yeah, exactly.
That's cool. Now, verse 20 talks about triangular numbers, but we could also think about, like, stacking these triangles to make a pyramid, right? A three-dimensional triangle.
Yeah, exactly.
A tetrahedron, is that the word?
Yeah, tetrahedron or pyramidal number.
Okay. And our provided text doesn't give a specific verse number for this, but the concept is closely related.
Right.
So if you think about it, you've got one at the top, then a triangle of 3, then a triangle of 6, and so on. The sequence would be 1, 4, 10. And there's a formula for this too, right?
Yeah, the formula for the nth tetrahedral number is n multiplied by n plus 1 multiplied by n plus 2, all divided by 6.
Okay, got it.
So if you had 4 layers, it would be 4 times 5 times 6 divided by 6, which gives you 20.
Now, this might seem abstract, but think about builders. Building stupas, those big dome-shaped buildings.
Yeah.
They need to count tons of bricks, right? And those bricks might have been arranged in layers that look like these triangles or pyramids.
Right. It's not just theoretical math.
Right. Real-world stuff.
Real-world applications, and it connects math to, like, architecture, maybe even their spiritual beliefs.
That's fascinating. Okay, let's move on to verse 22.
Okay.
This one's about sums of squares and cubes.
Mm-hmm.
It says, Varga yagad bivyashya, afagdad vigataikayuk.
Right.
Which means squares summed, sixfold. So this is a bit more complex. This verse gives us the formula for calculating the sum of the squares of the first and natural numbers.
Yeah, so imagine you wanted to add up 1 squared plus 2 squared plus 3 squared and so on, all the way up to, let's say, 10 squared. This verse tells you how to do that without actually having to calculate each square and then add them up.
Right. Okay, so what's the formula?
The formula is n times n plus 1 times 2 times n plus 1, and then you divide the whole thing by 6.
Okay, and n is like whatever number you're going up to.
Exactly.
Got it.
So if you wanted to find the sum of the first 3 squares, 1 squared plus 2 squared plus 3 squared, you would do 3 times 4 times 7, divide by 6, which equals 14.
Okay, and if you actually did it the long way, would it be the same?
Yeah, 1 plus 4 plus 9, that's 14.
Cool. Now, what about cubes? Did Aryabhata have anything about those?
So the verse doesn't explicitly give a formula for the sum of cubes, but his work shows he definitely understood it.
Oh, interesting.
And there's this neat connection between the sum of the first and natural numbers and the sum of the first n cubes.
Wow.
The sum of the first n cubes is just the square of the sum of the first and natural numbers.
Okay, so hold on. The sum of the first 3 natural numbers is 1 plus 2 plus 3, which is 6. Right.
And the sum of the first 3 cubes is 1 cubed plus 2 cubed plus 3 cubed, which is 1 plus 8 plus 27, which is 36.
Exactly.
36 is 6 squared.
Yeah, exactly.
Oh, that's pretty neat.
It's a beautiful relationship. And, astronomers back then studying the movements of planets and the moon, they probably used these concepts, like figuring out the paths of these celestial bodies might have involved squares and maybe even cubes for more complex orbits.
Yeah. It makes you think these basic series, there's like the basis for so much more complex math, even today in physics and engineering.
Absolutely, yeah.
So, all right, let's move on to verse 21. This one's about algebraic problem solving. It says, Ikavietsia, falasamula vijukta.
Right.
Which means the result with differences reveals terms. So this verse suggests a way to figure out unknown numbers in a sequence if you know the total sum and the difference between the numbers. Yeah, it's like if you know the overall outcome and you know the pattern of how the pieces are changing, you can work backwards to figure out the individual pieces.
Okay. And what's interesting here is that Aryabhata's approach, it wasn't necessarily like the algebra we learn today with X's and Y's.
Yeah.
It was more conceptual, right? Maybe even visual.
Yeah, exactly. It was more about understanding the relationships between the numbers and how they fit together.
Okay, so let's try an example, a king's riddle.
Yeah.
A king has 100 gold coins, and he wants to divide them into piles. The first pile has 5 coins, and each pile after that has 2 more coins than the one before it.
Okay.
So the question is, how many piles are there?
Right.
Now, Aryabhata's verse suggests that if you know the result, which is the 100 coins, and the difference, which is the 2 extra coins per pile, you can figure out the number of terms, which is the number of piles.
Hmm.
And while the verse doesn't give a direct formula, Aryabhata would have been able to solve this, maybe by picturing the piles around.
Yeah, he might have visualized it. And the answer, if you work it out, is 10 piles.
10 piles, exactly. And this shows how, for Aryabhata, numbers weren't just symbols on a page. They were like real things that you could arrange and visualize.
Yeah, and that's a really important aspect of early math. It wasn't just abstract symbols. It was connected to the real world, to things you could see and touch.
That makes a lot of sense. Okay, lastly, let's look at verse 23. This one says, Treoviyatya yoga gunivisha ketravat,
Right.
which means from sum and product, like a field. Now, this is about simultaneous equations, right?
Yeah, exactly. It's about finding 2 unknown quantities when you know their sum and their product. And the field analogy is really cool.
Okay, so explain that to me. What's the field analogy?
Okay, imagine a rectangular field, right?
Okay.
If you know the total length of all the sides of the field, the perimeter,
Okay.
which is related to the sum of the length and the width, and you know the area of the field, which is the length times the width,
Mm-hmm.
you can actually figure out the individual length and width.
Oh, I see.
And Aryabhata, he used the same logic to find 2 numbers when you know their sum and their product.
That's clever. Okay, so
Yeah.
give me a real-world example.
Okay, so imagine a gem trader. He's got 2 gems. He knows that together they're worth 50 gold coins.
Well,
But he also knows that if you multiply their individual values, it comes to 600. So what's the value of each gem?
right, so that's a tricky one.
Yeah. But using this field thinking, Aryabhata could figure it out. He'd think about the sum 50 and the product 600, and he could determine the 2 individual values.
And what are they?
30 gold coins and 20 gold coins.
Oh, yeah, that works.
Add them together, you get 50. Multiply them, you get 600.
See, and this was important for traders, right? Making sure deals were fair, knowing the values of things.
Absolutely, yeah. This ancient math was essential for everyday economic activities.
So wrapping up this deep dive, we've seen some really cool stuff from Aryabhata. Arithmetic sequences for merchants, sums of series for builders and astronomers, and even early algebraic thinking. And these Ganitapada gems, they show us a world that's built on mathematical patterns.
And remember, we saw in our previous episode how Aryabhata used math to understand the cosmos.
Right, the shadows and the Earth's circumference.
Exactly.
So he wasn't just a mathematician. He was a scientist, bringing together math, geometry, and astronomy. And we might use fancy tools today, but we can't forget that thinkers like Aryabhata laid the groundwork for all of it. It really makes you think. You know, all this math developed so long ago, it's still relevant. It's the foundation for the technology we use every day, computers, engineering, everything.
Yeah, it's amazing how these ancient ideas are still shaping our world.
And speaking of shaping the world, in our next deep dive, episode 17, we're going to be looking at how Aryabhata calculated the size of the Earth using just a well and the sun.
That's right. Building on some of the ideas we discussed in episode 15 about his astronomical observations.
Exactly.
So if you enjoyed today's deep dive, make sure to subscribe to the deep dive and maybe leave us a review. It really helps us continue to explore and share these fascinating pieces of ancient knowledge.
And until next time, keep exploring the connections between the ancient world and the modern mind, and keep an eye out for those mathematical patterns all around you. You never know where you'll find them.